Hey folks, Kevin here. Well, it's October 27th, 2025. It's 27 degrees this morning. I guess it's probably about 29 degrees Fahrenheit right now. My breath isn't showing up. Well, anyways, this video is basically to Todd. Todd, who's come out here in the past and helped me out with the demo work here and getting things moved out to the shipping containers and all. Really helpful guy. He's real busy working on his shop to get things buttoned up. And he became very concerned. I mean, he saw that this building had come down and he worked his butt off to try and keep his barn from collapsing as well. And he's got solar panels. He has a pole barn. I think it's probably a 412 pitch. I'm listening in case the Amish do show up today. Oh, one thing while I'm out here, I'm going outside for a second, Todd. So first off, Thea and I both thoroughly enjoyed your video, and that's just a private video that nobody can see yet, where Todd just sort of introduced his environment, the things he's into, and his workshop barn area and all, and lean-to, and his vehicles and his repair work that he's done. Very, very interesting, and I think making videos can be very, very beneficial for people. The one thing I would say, one quick tip on when you're shooting videos, don't have the sun behind you. You can't really see yourself that well when that happens, and you'll see I do that all the time in my videos, but I try not to do that. But Todd, like me, is somewhat anal retentive, wants once he makes an investment, he wants to rely on it, and hopefully it's going to be around for a long time, and it'll be beneficial. There'll be more rewards than the costs put into it. The value is greater than the costs. And he's been watching what I've been doing, how fast everything went up with the Amish crew and all, which he's familiar with. I think it's his brother-in-law who recently had a build done by the Amish and all. And has been watching some of the things that I've been doing, like the hurricane clips up there, the screws, the 8-inch screws that I use, the blocking being used here as well, and those sorts of things. And his trusses are, I think he's probably got a 412 pitch. He's got 4 foot on center trusses with, it looks like 2x4 purlins that the metal roof is attached to. And in a previous video, I talked about dead loads, live loads, and other aspects of considerations with buildings and all. And I created a video talking about truss permanent bracing and all. And I talked to Henry about how I wanted these trusses braced and all. And I think he did his best that he could do with it going up as fast as it did go up, and understanding what it was that I really want and all. So what I thought I'd do is discuss some of the things, because these trusses are not braced permanently based on my requirements, because I want this to last for my great-grandkids to be able to have this place and use it for years and years to come. So that's what I'm going to do, talk a little bit about what needs to be done with the bracing here. Now, I don't know how well this will show. I'm going to turn the camera up some. It would be ideal if I was up there right now. So if you have access, Todd, to your spec sheets, the engineered drawings for your trusses, that will be very, very helpful. Because on those spec sheets, there's going to be little rectangles showing 2x4s that are required for lateral bracing meaning, so the trusses span from east to west on this building. And so the lateral bracing or longitudinal bracing are like that 2x4 there on the bottom cord. All right, so let me just, for those of other people and all, the bottom cord is that part of the truss that sits on top of your top plates. So that's the part that you'd attach your ceiling to. The top cord is a part that your sheathing or your purlins and your metal roof are going to go on to. Then you're going to have vertical supports. Let's see if I go over here. This roof is lower. You know what I'm going to do? I'm going to bring a ladder over here so I can get up here and show you what needs to be done over here. Bear with me a moment. Okay, so right now I'm on a 8-foot ladder, one of my orchard ladders, and I'm up here and we could see inside of one of the mono trusses. So this is a 10-foot tall ceiling over here. And what we have is we have the vertical support over here that happens to be up against a 2x6 wall that goes over there, but there's a vertical truss, a vertical support here, a diagonal support web here. So these are diagonal webs. This is the central vertical support. This is the bottom cord. So this happens to be a 2x4 here, and it's a 2x6 up there. So they've got one 2x4 that runs the full length here of this section. So, and this is only a 16-foot span here. And these trusses are 2 foot on center with a plywood 5/8 inch sheathing, a little bit 23/32 sheathing up there. Okay, so this is not adequately supported in my opinion. So let's just talk about the bottom cord first. So we have one longitudinal support here, and if you look right here, and these are probably 3.5 inch long or 3 1/4 or 3.5 inch long wire nails. You don't want to use screws. Nails will give some, and that's really important. Here, what most people do, they split it right in the center. I don't know, is this showing up here? So there's two 2x4s end to end. Now the way I would do it is a little bit differently. I'd have two 2x4s next to each other, and I would end this one here, but I'd go the full length, full width of this truss here, and I have the other one here, and I'd have a double all the way down with a joint not matching each other. So I wouldn't put two joints there. I put a joint like half of the span. That's me. I'm anal retentive. Okay, now and I'll go over this in a couple of moments, but the dimensions of this 2x4. So this 2x4 has two different dimensions that we're going to talk about. So we have the crowning and bowing aspects of this. So this vertical support here can bow laterally, bow this way. The crown is this way. And these, with a heavy snow load, can start to deflect and bow to one side. So by also having another longitudinal 2x4 going the full length from gable end to gable end, going all the way down, that forces an uneven, heavy snow load from bowing some of these and starting the whole cascade of a collapse. So that's one brace that needs to go down the full length of this. The other thing that needs to happen is now this is 44 foot long. There should be 45-degree diagonal supports as well. So you can attach, trying to get the camera here to do what I want it to do here. So you can have a 45-degree diagonal support going from this vertical support going up. Geez, Kevin, let's get this camera to go up to the top. A nice 45-degree angle, and putting those every, let's say, 10 feet. You could put one on each side. So I know these are 2 foot on center, but even with 4 foot on center, getting both a longitudinal, a lateral support, a wind brace, whatever there, that keeps, when the weight, uneven snow loads get on these structures, it'll help to keep any of these from bowing laterally. And by having a diagonal support, that's important. Also, when I talked about the bottom chord, I believe that we should have diagonal support. So let's say from that corner over there, going at a 45-degree angle, coming over to here, and then from here going over to there at a 45-degree diagonal as well. So we have both longitudinal or lateral supports and 45-degree angle diagonal supports. Now, this particular ceiling, which is going to mount on the underside of here, will be 1/2-inch plywood, and there'll be a couple of inches of closed cell insulation, spray foam insulation, which will act as a rigid structure as well from the underside. So I'm really overdoing it as far as what most people would do, but it's what I think is best. So bottom chord needs a longitudinal brace and 45-degree angle diagonal braces. Vertical supports need a longitudinal brace going down the full length and 45-degree angles, especially, and I'll talk about at the ends there in a moment. Then we have this web support here as well. This needs a longitudinal support as well, and a 45-degree diagonal supports as well. So all of these can bow laterally as well. I hope that makes sense. All right, I'm going to get down again here, and I'll try and show you T and L supports, which if I had trusses that were 4 foot on center instead of 2 foot on center, I do a combination of T and L supports as well. And the T or L supports can be your bracing for both your gable ends, as well as supports for these vertical or even your diagonal web supports as well. Sorry, I'm not operating this camera very well. Let me get down to show you what I mean by that. Okay, I'm not sure how I'm going to demonstrate this, but I've got a 12-foot 2x4 here. And what I'm going to do is I'm going to look at it for crowns and bows. Whenever we're framing something, whether it's a floor or a wall, we want to evaluate each board for its crown and bow. You also want to check for checks, cracks, rakes, and all the things, I guess. I don't remember all the terms. But anyways, let me see if I can get this camera to show this. So as we look down this board here, we're looking for lateral deviation to the left or to the right of this board. And I don't see much of a deviation there myself. There's a slight crown going from my left thumb here to at the center of the board. It goes to our left, to the side of the thumb, and then traverses to the right. But when you look at it this way, you could see a bow down the length of this. Hopefully that's showing up, that this is curved that way. So in order to prevent bowing, and all right, so 1 second here. in order to prevent bowing, like these 16-foot 2x6s, without this blocking here and without the screws that I put in here to hold everything together, they all had little bows to them. They would move laterally. And even with like the 10-foot wall over here, let me show this. When they did this, they moved along quickly, but this 2x6 has a bow that bows like this. Therefore, when the 45 or 90 degree angle straight here, where this board is 3/4 of an inch right here that way compared to the base and the top. Because when they put this stud in between the top plate and the bottom plate, they have them exactly 16 inches on center. But this one here was bowed this way, and therefore you could see a little bit of light, and when they went to nail it, you'd see nails missed and all. So that's a bow to that. The more, without the structural sheathing here, the more weight that goes down on the top of this, the more that these studs can bow to the side. So what can we do after a structure's up? I'm sorry, I'm putting that light behind me. When we discover that we want to prevent a bow from happening. Well, one, we can put that longitudinal brace, oh God, Kevin, that longitudinal brace down all of those webs or those vertical supports, or like this one here, we can see there's a bow to this. So how would I fix this? What I would do, let me grab a different 2x4 here. Now, we'd want this to be the same length as whatever, let's say it's a vertical or one of the diagonal supports up there. We'd either make it a T, like this. Geez, get that camera to look. All right, so that would be considered a T support, or you'd make it an L support, like that, and that would straighten out the bow. Oh, gosh, if that makes sense. All right, so the goal is to reinforce that vertical support or that diagonal support before it gets, so if I had 4 foot on center trusses, I'd go down each one of the webs and put T's or L's going up, and I'd only use like 3.5 inch wire nails in there because screws will snap when that load gets on them. Then after you have that T or L support going down, now if you have them 2 foot on center, a T or an L would be enough as opposed to the horizontal bracing, if that makes sense, or even the diagonal bracing. But that T or L support can really reinforce things a lot. And if I had trusses that were 4 foot on center, I'd put the T or L braces on and then add an additional horizontal brace, a longitudinal brace going all the way down the end. I hope that makes sense. So we'll look up here at our trusses over here. I'm not sure. It's hard for me to even be able to see this. So try not to trip here over the boards I got laying. So we have at the base of this vertical over here, we have a longitudinal support, and that is going to keep the bottom cord from shifting either way. We see on that diagonal we have a 2x4 going longitudinal. Now that was called out in the spec sheet. This was called out in the spec sheet. That was called out in the spec sheet. Then we have this one over here. I believe these two were called out on the spec sheet as well, and this one. But you notice the vertical supports here, if enough weight is on there, they can start to bow laterally. So either I could put a T or L on those, or I could put an additional longitudinal 2x4 or 2x6 going all the way down the length, and then at each end, put 45-degree bracing on each end. Hopefully this is making sense. On this 2x4 that is on not a 45, it's probably it's over a 30-degree angle. You could see that diagonal board there should have, besides that longitudinal support, should have some 45-degree angles, probably every 20 feet at least. So, and you could put one on each side of that diagonal support. And I will actually put more, I'll probably put 2x6s going down there, even though this will have plywood on the sheathing on the underside of this as a ceiling. I just want to make sure that when we have uneven snow loads, high winds, really tremendous snow loads on here, and the snow doesn't shoot off the metal roof that goes over this plywood roofing, I want to make sure, when I'm in my 90s, I don't want to have to worry about getting up there and getting the snow off. Hopefully that makes sense. All right. Hopefully this is somewhat helpful. So T and L supports can be a replacement for some of the horizontal or diagonal supports. But I believe that your bottom cord needs both longitudinal bracing, permanent bracing, as well as diagonal bracing. I believe that your webs also need longitudinal bracing as well as diagonal bracing. I believe that the gable ends, oh, this is another thing. So let's say a gable end down here, high winds can make that sort of, there's a tremendous amount of surface area. Now this is our south, and very seldom do we get winds out of the south, but that could really push against here. So we can have 45-degree angle bracing. Sorry. I'm sorry with the camera here. I'm having a hard time today. So we could have 45-degree bracing coming down and hooked to those ends. But one of the things that I think might be beneficial would be creating L's out of 2x6s. So I'm going to take two short boards here. Let's say we take two 2x6s and we put them together like this. And we nail this 2x6, or this one here, whichever one you wanted. All right, can I do this? Imagine this is an L up against the full width. Oh, Kevin. Imagine this is an L and a vertical board here on top of this. The full width of the gable end of the trusses up there. And then off of that, we have a 45-degree angle coming down from the ends. That would, we have a few of those. So that would be really good as well. So these are all techniques that have been done for years. And like even right up here, those studs there, that's just 8-foot tall studs. They should have blocking in there to help support them as well from bowing, unless I do what I did down here, is I put the rigid foam between each stud, which basically is a tremendous reinforcing force there. And then we put the plywood sheathing on that as well. So bracing is so important when it comes to your structures, your buildings and all, if you're living in snow country. So anyways, I know a lot of what you see me doing looks like overkill, and hopefully it is. Hopefully I never have to worry about these things happening in the future, the things that I've seen and the things that I've experienced happening in the future. So the building that I first built here back in the early 80s was a pole barn, 6x6 posts, 6 foot on center, with trusses 4 foot on center, with purlings and a steel roof on this roof and an aluminum roof on that building. And the posts rotted through. The ground is too moist here. And that's one of the things I would say is understand the pressure-treated manufacturer's limited lifetime warranty or the 30-year warranty and what you have to do to ensure that. Do you have to coat the bottom of those posts when you put them in the ground? That may be a requirement. Are you using hot dipped galvanized nails or stainless steel nails, which are required by some of the manufacturer's requirements? You know, it's just kind of crazy. And when I went to see what our warranty was years ago, when we rebuilt this building, so this is the second time it's been rebuilt. So I originally had a gravel and then clay floor in here for the horses, and then wildlife after that, but that was a pole barn. And when I took and saw that the 6x6 posts were all rotting at ground level and below ground level, I knew that, well, the building needed to be supported, so I hired a friend to support the building, dig it out and put a footer down, put block walls up, and all. And then you saw what happened, but instead of it being 4 foot on center, the trusses, I said, let's double them. And the new trusses, lumber nowadays isn't as good as it used to be. And I think I demonstrated that when I was doing the demo work, taking the building down. The density, these are rapid grown timber nowadays. This stuff it weighs, you know, like 1/3 the weight of the boards that I had, comparable dimensions in the 80s. So lumber isn't the same quality as it used to be. And therefore, I think we need to engineer, we need to design and build our structures, thinking about, hey, things aren't what they used to be. We need to do more to help maintain the structural integrity of these buildings. Okay, I've gone on way too long. But Todd, let me know if this is at all helpful. And I'll make sure to show video as I start doing this work as time permits. Anyway, oh, here's one other thing. This header here is like a standard header. And you see we've got a couple jack studs, we've got the king stud, we've got jack studs above it there to go up and help hold. So this is done like standard builders do. But you look at these ones here, I went beyond, you know, I've got multiple jack studs there and the king stud way over there, but I have the nailing, a lot of nails all the way around. Now there's still more nailing that's got to be done. The bottom of that top plate that holds that header needs to have nails put up into there as well. So, you know, it's like all of these little things make a big difference when everything's done. Now these will all have plywood on this side and that side of that. There'll be plywood on this side as well, plywood on the ceiling. And that plywood, if nailed properly, will really enhance the structural integrity. By using a closed cell spray foam on top of, between the truss bottom cords up there, on top of the plywood ceiling, that will increase the structural integrity of the build as well. So, yeah, all of these things may be overkill, but I'm hoping that I do it once now, and I'm done for the rest of my life. And my legacy to my kids, grandkids, great-grandson, well, they'll have this for them to use for years to come. Okay, that's it.